Hi there, welcome back. And now we are going to work on another LeetCode problem. This is 105 and is construct binary tree from preorder and inorder traversal. Alright, given two integer array, preorder and inorder, where preorder is preorder traversal of a binary tree, inorder is the inorder traversal of the binary tree. Construct and return the binary tree. Okay, so we have an integer array. We are given the integer array preorder and inorder. From here, we would like to construct the binary tree. It's pretty clear what we will need to achieve. Let's look at some examples there. Input examples 1. We have preorder given by 3, 9, 20, 15, 7. Inorder, we have 9, 3, 15, 20, 7. Okay. Now this tree would look like 3, and the left there is 9, and the right there is 20, 20 there are children, 15 and 7. Okay. So let's see. Preorder we have 3, 9, 20, 15, 7. In order there is 9, 3, 15. 9, 3, 15, 20, 7. 9, 3, 15, 27. Okay. Seems correct like that. Second examples. We have preorder -1, inorder -1. So output is -1. Just one note. Okay. I think I understand what we need to do here. What the problem description is asking here. I would like to ask a few clarifying questions. What is the size? And here we are given that the length is between 1 to 3000. Okay, so we are given at least one node. Then I'm going to assume that the preorder and inorder are valid. Alright. Now let me explore some possible implementation for this. So off the top of my head, I can see that the preorder uh, can be used I think we can start with the preorder. So we have 3, meaning that the root would be 3, and the next one it would be 9 and 20. And it was so okay. Okay, I think I need to write down some notes here of our findings. So in order can be split into 2 at the root node. At any point, the left the elements before the root node would be the left would belongs to the left subtree, and vice versa. For the right subtree, it would be all the elements after the root node. Okay, so now I think this sounds reasonable. I would like to start coding unless there is further optimizations that you would like me to explore. Alright, I guess that sounds good. And now let me try to come up with an implementation for this problem. So how are we going to do this? I'm thinking that we can use the preorder as a basis. So I'm thinking that we can use let's see. So if we use the for loop by going through the preorder, then we will get the root node first, and the next step will be create the type. And for that, we need to check if the 9 appear before or after 3 in the Inorder. So I'm thinking of some way to split the Inorder more efficiently. I think here is another observation. So once we create a node 3, we need to check whether there is a left subtree in the Inorder. So what we can do is we check the first element. Is it a 3? Because if the current node has no left subtree, then we know that the Inorder would have the current node appearing before anything else. So I think we can write down the observation for create node 3 preorder and check if it is the first node found in Inorder. Yes, then no left subtree. No, there is left subtree. So if there is a left subtree, then we create the left child, and then we continue on. Okay, so for the first example, let me work on this on the next page instead. So first example, Preorder is 3, 9, 20, 15, 7, 9, 3, 15, 20, and 7. So first of all, we create 3, and then we see there is a 9, and then we check that the first element is not 3, so 9 is the left child. Then we say that, oh, so in order there is 9, so we can move on. Now there is a 3. I guess we need to use a stack that. Okay, let's create a stack. Okay, let's just do it later, but let me assume there is a stack there. So stack could be, anyway, let me just write it smaller here. Stack will be 3, 9, now 9 is crossed, 3 is crossed. Now 20 is the right track now, because there is, we have found the root node in the Inorder. Then 20 we have 15, 15 maps with the left one, and then 7. Okay, I think that works. So we can keep on. So this would mean that we can move from the pre-order towards the end of pre-order, while at the same time we can check the in-order to see if the pre-order is the left side or the right side. Alright, so I'm thinking whether we should start with the in-order instead of pre-order. So in this case, if we start from the in-order, we have 9, and then we have 3, then we can tell directly that 3 is the parent of 9. And then 15 would be either the right child of 3 or the parent of 3. So how do we tell that? Well, I guess we can tell from the pre-order. So let's see if we build the 9 first, then we create 3 there. Now the pre-order has 3 and then 9 on the left. So yes, so I think we need to keep on switching back and forth as to when to use the pre-order or in-order list. Let's see. So Inorder is definitely a way for us to get started. Um, so if we use the Inorder, then alright, so I think we need to use both at the same time. So first of all, if the Inorder is not matching the preorder, preorder is on the top level. I think what we can do is if we use the Inorder, then we kind of know the level of each element there. So for example, there is a 9 in the there is a 3, we start at 3, so 3 adds uh, the highest node there in the binary tree, and then if we go to the left, then we have the 9. So how do we know that 9 is on the left subtree? How do we know that 9 is on the left subtree is by using the Inorder, because we see 9 is before, it comes before 3, so it is on the left subtree of 3. Given that, we know that 9 is the child of 3 directly. And so we can move on because we have found the 3 in the Inorder as well. And everything after that will be on the right, on the right subtree of the output. So now the next node we have is 20. Then we know that 20 is the child of 3. And the next element that we see is 15. To determine whether 15 is the left or right child, then we are gonna need the Alright, so if we, how about this? Because it is a pre-order, then it's level by level. I guess it makes more sense to start with the Inorder, because we start building from the left. So I guess we can start from the Inorder, and then we keep on building on top until we found the nodes at the pre-order. So let's say we have 9, 3. So we put in 9, 3, and then we pop up the pre, and then we now have 20. So the in order at 9, 3, and then we have 15, 20, and then 20, we see that 20 is in the pre-order. So then we can connect both of those as the right track. Then next we see a 7. Okay, I think that kind of worked, but I'm not sure if that worked in other examples. I guess it could work because in order is printing from the left to the right and then the right. And then we can use the pre-order to determine whether the current node is part of the. Alright, so maybe let's look at another example. I will come up with my own examples. So here we have 1, 2, 3, 4, 5, 6, 7. So the pre-work looks like 1, 2, 3, 4, 5, 6, 7. And the in order, this would give us 4, 2, 4, 5, is it? Yeah, so 4 to 5, 1, 6, 3, 7. Okay. So if we build it from the beginning of Inorder, so we have 4, then we have 2, then we have 5, and then we have 1. Alright, so my original idea doesn't work. But from here we can tell that 1 is the root. Now 2 is, so we know that 4 to 5 is on the left side, the left subtree. But how is it ordered? So we know that there is a left subtree of 1 because the in-order doesn't begin with 1. Then the chart must be 2 there. Okay, so 1, 2. From 2, how do we know that 2 has a children? We need to check that 2 is not at the beginning of the in-order. Can we just build this recursively? I'm wondering if that is the case then. Because once we know that the root is 1, we know the left subtree is all of the in-order up until 1. So 4 to 5 is on the left. So 4 to 5, and then 6 to 7. But now we also know that 2 is the root there, because right after 1 in the preorder we have 2. and we know that 2 has a left child, which is 4 and 5. Now, on the right side, we see that there is 3. Then we have 6 and 7. So I guess this could work, except that the complexity, I think we need to go through it multiple times. I think could be n squared complexity here. Interesting problem. Okay, let's see. If we have 1, 3, preorder. Okay, so I guess once we know that, once we know all the elements that belongs to the left side tree, could now tear the tree apart. So let's say we have 1, and then we know 1 is at the root now. So what we can do next is that we can split out the tree. So we see that here now that we know 1 is at the root, and we know that the left has all the elements of 4 to 5, then we can continue with our checks there. we also know that the preorder of the left subtree is 2, 4, 5. So I think we can do that recursively. Yeah, I think that makes sense. So if we do 2, 4, 5 recursively on the left side, we have 2. Then we can again recursively create the Inorder. I think that should work. But I would like to check again the requirement there. Okay, so we are given a hint here. Preorder and Inorder consist of unique values. Alright, so I think that makes our solution a bit more efficient. So we could create an additional space to store all the elements there and in the index, so that we don't need to look through the Inorder repeatedly. Right? Does this sound reasonable to you? I would like to start implementing, unless there is a further optimization you would like me to explore. I guess the answer is no. So here, first of all, what I'm going to do is okay. So let me first of all create a new variable. So I'm gonna call it index. Then I will look through the Inorder for I, comma x in enumerate Inorder. ID x of x equals I. Okay. Now I'm gonna create another function so that I could build the graph recursively. What I'm gonna do is I will create a function. Let's call it construct. Then we receive the preorder, then Inorder. Okay. So I'm gonna forget about the optimization for copying and stuff. This to simplify our implementation. So preorder, I'm gonna create a new node. So node would be, so I'm gonna create a node 3 or 4 is, let's see, preorder 0. Okay. Actually, I might not use the index here to simplify things. But let me think about it. Okay. Anyway, so let's call it the left pre and the right pre. First of all, I will check the in order. So for I, comma x in order, if x equals not dot down, then we're gonna break. Okay. Then we will check if we're gonna call it left in equals in order up to I, and then write in order from I plus 1 towards the end. And then if left in, then what you're gonna do is not dot left, to split up. So left 3 equals x for x in preorder if x in left in, and also the right 3 x for x in preorder if x in right in. Then we will set the left and right. So not dot left equals construct left 3 and then left in. Same for the right side. Construct right 3 and right in. Then at the end we return not. Okay. Oh, don't forget in the beginning, if it's not in order, then we return none. Okay. Alright, now let me quickly go through the code again to make sure I don't miss anything. Here I check whether the Inorder is empty. If not, then I create a node for it. And then I'm going to create is the preorder one, because preorder we print out from the root, and then we print out all the check. So now we know that the current node must be the first element in the preorder, and then we can use the Inorder to find out where the split of the element is. Then we know that the left in is all the in order. I mean the in order for the left subtree is all of the elements in order before the current root, and likewise for the right, it is all the values after the current root. So given that, we can extract all the preorder of the left subtree from the preorder, and likewise the right subtree preorder. Then we can recursively create the left and right subtree, and then finally we can return the current root. Now let's go through the examples to make sure we got what we expect. So first example, we have 3, and then the left one is 9, So there's only one, so we create 9. And then we are gonna create 20 next. On the right hand side. And then in the left we have 15. On the right we have 7. For the second examples, we have 1. And in the left we have 2. 4, 5. The right hand side we have 4 there. Hold on. Okay, so it's 3. And then we split that, we got 6. That's 7. So I think it works. But let me put it into LeetCode to make sure it does as expected. So if not preorder, return none. Not equals 3 minute or preorder 0. Then for I, x in order that minute and numeric if x equals not dot l, then we break. And then what we're gonna do is have in equals in order up to I, then the right in be the remaining. Okay. Now the pre would be x for x in preorder if x in left in, and same for the right. Okay. Now not dot left equals self dot build tree left tree and left in. Same for the right. The end we return the node. So let's try run it. Okay, we got what we want. Now let's try to submit it. Hopefully we won't get any wrong answer here. Okay, seems a bit slow. Worried that we might got TLE at this point. Yeah. So we got TLE with this. So what can we do? see how many questions we got it right. So yeah. Okay. How about this? Instead of creating the left tree, we're gonna check instead. So let's do this. While for x in the order a3 in order, then look. I think we still got the key in here. Let's call it in order set in order. I think this may not be the most efficient solution, but try it out. Yeah. It's very slow. It's taking quite a lot of memory. Let's see how we can optimize this. How about we use 1100 so that we don't need to slightly early. Okay, let me try that one real quick. What's happening here is kind of error. So I'm trying to avoid copying and recreating the list. And we kind of get this error now. 53, 94.
Okay. Mm. So, so this one's ended here. Still here. Mm. Mm. So now we need to optimize this one. So I'm thinking we should do it recursively instead. Iterate it. Okay, I think we'll stop here and then I will try to make another video as a second attempt. So thank you very much.